This
some of
conference
the
will now
concepts
be
with
recorded.
respect to the C programming. So this is an interview preparation session, and here we will be discussing the things which we have already learned in the C module. So we will have major topics discussed one after the other with certain good number of examples taken. And we will just concentrate not on the complete very basic things. We will concentrate on most important things which are required for the interviews going ahead. So any technical related things will all be taken here from today's session. So today we will be looking into some of the operators basically. So because this is the very first session, so we will first look into the operators, and once they are done, we will move with the next going topic. So I hope the screen is all visible. Please make sure each one of you are responding to the questions. We will just be taking up some of the examples on each of the cases. Okay, so to start with, what is an operator? So, if I have to tell you what an operator is, it is actually a character which represents some operation to be done in our C programming. So, we have got several kinds of operators in our C programming. First of all, the operators are categorized with respect to the number of operands it takes and also with respect to the type of operation it does. So when it comes to the number of operands it is taking, the operator is divided into unary, binary, and ternary operators. And when it comes to the operation it does, we have got several kinds of operators. To name some, there is a bitwise operator, there is arithmetic operator, logical operator, relational operator. So all of this, very few things as an example will be taken in today's session. So the very first type of operator, we are going with an arithmetic operator. So tell me, which are the arithmetic operators available? Which are the arithmetic operators available? Yes. So we have got some of the arithmetic operators like addition. So there is subtraction, there is multiplication, there is division, there is modulus, and along with this, we also have got increment operator and the decrement operator. So these are some of the arithmetic operators available in the C programming. So anyways, you know the basic ones. Plus is meant for doing the addition, minus is meant for doing the subtraction, star for multiplication, forward slash for division, percentage for modulus, plus is the increment, minus is the decrement. So what does a modulus operator actually give as an output? When do we usually use a modulus operator? Yes. So any modulus operator you take is meant to give me remainder as an output. So we expect the remainder to be obtained when a modulus operator is being used. Can you tell me what does 15 mod with 4 gives you as an output? What does 15 mod by 4 give you as an output? Yes. So 4 threes are 12. The 15 minus 12, the remainder will be 3. So 3 will be given as an output. Similarly, what is 23 mod by 6 given as an output? What does 23 mod by 6 give? Yes, remainder will be 5. So to get the quotient, what operator should you be using? To get the quotient, what should be used? Yes, so it should be the division operator. Here we are using mod to get the remainder of the output. So very basic arithmetic operators are already well known to you. Now let us move to the increment and decrement operators. So when it comes to increment and decrement, both of them are literally been there to change the value of a variable just by 1. So if there is 10, I might want it to be 11. If there is 12, I want it to be 13. If there is 5, I might want it to be 4. So just to change the value by 1, we will go with increment or decrement operator. So when it comes to increment or decrement operator, we have got two things. One is pre-increment or decrement. The other one is post-increment or decrement. So it is called as pre when the increment or decrement operator is used before the operand. So for example, assume there is an integer variable called x with the value 10. If I am using plus plus before the variable x, that is called as pre-increment. And if I am using plus plus after the variable x, that is called as post-increment. So now where lies the difference is, first of all, in case of pre-increment, the change what you are observing happens immediately to the variable. So plus plus x will change the value of x to the next value immediately when this is being operated. So that is pre-increment or pre-decrement. When it comes to post, the change will be reflected for the next time you access the variable. So the change will not be seen in the same variable. You're going to see it for the next time you are accessing the variable. Now let me take an example. There is a variable called y which is being assigned with the value plus plus x. Similarly, I'm taking a variable y which is being assigned with the value x plus plus. So what will be the value of x here at this particular stage? What will be the value of x? This is pre-increment. Change happens immediately in the same stage. So x must have to be updated to 11. And what gets assigned to the variable y? What gets assigned to the variable y? Again, 11 gets assigned to the variable y. So you change the value of variable x immediately, and that immediate changed value will be assigned to the variable y. This is in case of pre-increment. Now when it is in post-increment, I have told you just now that the change will happen for the next time you access the variable, not in the immediate stage. So because the change is not happening to the immediate stage, whatever value is being present will be taken as it is without changing it. So what is the value of x at this particular stage? If it is 10 plus plus, the value considered is just 10. Then what gets assigned to the variable y? The variable y gets assigned with the value 10 again. So see, only for the next time, in the next statement you access the value of variable x, you will be able to see the change. In this particular statement, both x and y will have the value 10 and 10 seen. So screen is not visible. Is it still not visible? Now visible? Okay. Okay. So as I'm saying, post increment is changing the value of the variable for the next time you are accessing. So y is being assigned with the value 10. After this, whenever I'm going to see the value of variable x, it must have been updated to 11. So in this particular stage, x will be 10 and that 10 will be assigned to the variable y. Because I did x plus plus for sure, for the next time when I access the value of variable x, it must have to be updated to 11. So this is the difference between pre and post increment operator. Now answer this question. Assume there is x having the value 0. So I do something like this. If x plus plus. So inside this I'll say printf if. Okay. So similar to this I'll go to the else part. If this is the one to be executed, I'll say printf in. else. And after this, I might also want to print the value of x. So tell me, what is the output of this? Else part will be executed. Else, and what is the value of x? Yes, else will be executed and the value of x will be 1, because if it is x plus plus, I am considering it as 0 plus plus. So 0 plus plus at that particular stage, value considered is 0. Because the value considered is 0, this has to be treated as false. You should know that any non-zero value will be treated as false. Sorry, any non-zero value will be treated as true and just a 0 will be treated as false. So this is false in this case. Hence, I have to go to the else part to print I am in else. After the else part is been printed, I want to print the value of x. Anyways, I have done x plus plus for sure. So x must be changing at the next time when I'm accessing the value of variable x. So this has to give me the output as 1. Okay. So similarly, so x assume has been 0 and this time I'm going with plus plus x. What will be the output? I mean if with the value 1. Okay. So what happens? X is being initially 0 right now. So I have told you that pre-increment changes the value of the variable immediately at the same stage. So this is plus plus 0, which will be seen as 1 for the in the same stage. So 1 is some non-zero value which has to be treated as true. So I have to enter into the if block to get I am in if printed, and I have to print the value of variable x. So variable x has got updated to 1. So this has to give me the output as 1. Similarly, assume I do something like this, just a printf. Okay, in none of these blocks. So I go with like this percentage d, comma percentage d, percentage d. Okay, so then I do something like x plus plus, then plus plus x, then plus plus x, then x plus plus. So what do you think the output of this statement is? Means this function, printf function. So assume, okay, I should give you the value. Assume x is having the value 0. So what will be the output of this printf? 3320, undefined, error, error. Okay. So first of all, this is definitely not an error. You have the authority to do this. This doesn't throw you any error, but the resultant is an undefined behavior. The reason is in one particular stage, okay, in one particular statement, changing the value of a single variable for more than once using more number of pre or post increment or decrement operator leads to undefined behavior. So usually a pre and post increment or decrement will be used only for once in a given statement. So if you are using it for more than once, then that might lead to an undefined behavior. Undefined behavior is not an error. You still end up getting some output which is not as you are expecting it to be. So this leads to an undefined behavior. Hence, make sure you are not using more than one pre or post increment or decrement operator for more than once in a single statement. So if there is any semicolons termination, then there will be multiple statements seen. So here, as you can see, all of these have been in a single statement. Using more than one pre or post increment or decrement in the same statement leads to an undefined behavior. Now, let us go with the next example. Assume there is an integer variable called x with the value 10, also an integer variable called y with the value 4, also an integer variable called z. So I do something like this: z is equal to x divided by y, and I want to print the value of z, percentage d. So what will be the output in this case? 2. Okay. So the reason why this is 2 is, here I am doing z is equal to x divided by y. The data type you are observing is integer divided by integer. Integer by integer always gives you an integer as the output that has been assigned to an integer variable. So when I do this, it is 10 divided by 4, which has to give you a integer value, that is 2. 2 gets assigned to the variable z. Hence, you end up getting the output as 2 here. Okay, it will be a 2 here. Now, next change. I'm taking integer variable x again, y again as an integer, and I'm taking a float variable called z, and I do something like z is equal to x divided by y. So now when I print the value of z, what should that give me? I'm going with percentage f format specifier because z is a float. Okay. So yes, this has to give me 2.000. That is because z is equal to x divided by y is what I have taken. So that means z is equal to, x is an integer, y is also an integer. So integer divided by integer gives you an integer. Hence, if you do this, z is equal to uh, 10 divided by 4 has to give you 2. 2 is being assigned to a variable of type float. What is happening here? In the assignment, you are seeing the mismatch. You are assigning the integer to a float variable. So is that a type promotion or a type demotion you are seeing? Correct, implicit typecasting is happening. We have a name given to it when there is an assignment. Yes, there is type promotion happening where an integer is promoted to a float variable. So integer is been 2. 2 is been assigned to the variable z. Because I'm using percentage f format specifier, percentage f has to print 6 numbers after the decimal point. Hence I get 2.000000 printed. Now, in the same thing, I want the output to be 2.5. I want to change this output to be 2.5. What should be in that? What should I be doing in that case? Percentage G. Percentage G will print the value present in the variable Z. Correct. I have to be typecasting. So, okay, if I typecast, do you think this kind of typecasting works? What will be the output in this case? What will be the output in this case? Okay, so this again gives you a 2 itself because I'm first performing integer by integer, which gives you an integer. After the integer has been obtained, I'm typecasting it to be of type float. So integer by integer is integer. Integer is later, after the operation is done, it is converted to float, which was actually not necessary. Again, in the type promotion, things would have happened the same way. So, in order to make this work, remember any one of the variable has to be of type integer. Okay, any one of the variable has to be of type float. So now what's happening? Z will be equal to, there is first variable x which has to be treated as float. I am telling the compiler to treat the variable x as float. So this is explicit typecasting. Okay, me being the user is telling that the variable x has to be treated as float divided by integer. And what is the rule of the operator? There's one rule of the operator. What is it? What is the rule of the operator? Remember the rule of the operator? It says that its operands should always be of same data type. Okay, operands should be of same data type. Here, to the division operator, if you are observing, one is float, the other one is integer. Because of this, there is a mismatch between the operands of the division operator, for which a lower rank data type will be converted to a higher rank data type. Am I not audible? Okay. So I was telling here that there is a rule of the operator which says its operands should be of same data type. So I want the operands of the operator, any operator given, to be of same data type. So first I'm taking is a float and the next is an integer. So there is a mismatch between the operands I have taken. So for which the lower rank data type will be converted to a higher rank data type. So implicitly what happens to that particular statement, there will be float divided by float seen by the compiler. So 10 divided by 4 this time is float divided by float, which is giving you 2.5. So what does that print? It prints the value 2.500000. Because I'm using percentage %f format specifier, I will get the output to be like this. What is it if I want the output to be 2.5? What format specifier can I go with? Yes. So you can go with percentage %g format specifier, which doesn't print the preceding zeros. Okay. So these zeros which are unnecessary will not be printed if you go with percentage %g format specifier. Okay. So yes, this was about the typecasting. Now let us go with the next operator. This was about the arithmetic operator and typecasting. Percentage %0f is not possible. Point %0f is not possible. That means you are saying after point you should go with zero numbers. So if you want certain number of digits to be printed after the decimal point, you have to go with percentage %0.2f if you want two digits after the decimal point, or percentage %0.1f if you want one digit after the decimal point. So precision has to be specified, like how many number of digits has to be printed. In such case, here I might get 2.50. If I use this, I'll get 2.50. For which percentage G is easier to get, just 2.5. Okay. So fine, let us go with the next. This is about now the logical operators. So which are the logical operators available? Which are the logical operators available? Yes. So we have got logical OR, we have got logical and also logical NOT. So there is NOT, logical and logical OR. Now, when it comes to logical OR, which is represented by two pipes, remember it takes two inputs. If the first input is false and second input is also false, output will be a false. So if it is false, the next one is true, output will be true. True, false will be a true, true, true will be a true. So in case of logical or any one input is true, output is true. Okay. So similar to this, we have got logical and in case of logical and, so if any one of the input is false, output will be a false. Okay. Okay, you also can say like that. If any one input is high, the output is high in case of a logical or. Any one input is low, output is low in case of logical and. So any one input is low, output is low. Now, when it comes to logical NOT, okay, so here a NOT of true will be false and a NOT of false will be true. Now, can you tell me what are the outputs you might expect after a logical operation is being done? After certain logical operation is being done, what can be the output? Yes. So any logical operator you take, the output will be either a 0 or a 1. Okay, output will be 0 or 1 to indicates false or true. Okay, output of output of the logical operators will be 0 or 1, which indicates that it is either false or true. So now let us see. Assume I have got a variable called x with the value 10 and y with the value 12. So what does x logical or with y give you as an output? What is, okay, so x logical or with y, in place of x I have got 10 and in place of y I have got 2. So any non-zero value will be true, hence it will be true logical or with true, which gives me true as the output. And if you want the decimal equivalent of this, it has to print you a 1. Similarly, what is x logical and with y? X logical and with y? Yes, again is true because I'm taking 10 logical and with 12. So some non-zero value is true, logical and with another non-zero value is true. So it has to be a 1 printed. Similarly, I'll take x as 10 and y as 0. So what is x logical or with y? So yes, it is 10 logical or with 0. It is true logical or with false, which has to anyways give you true, hence decimal equivalent has to be 1. Similarly, what is x logical and with y? Yes, it is a false. So it is 10 logical and with 0, which has to be true logical and with false. So it has to be false, whose decimal equivalent has to be 0. Okay, what is not of x? What is not of x? So it is not of 10. That means it is not of a non-zero value true. Not of true has to be false. Hence, false decimal equivalent is 0. Similarly, what is not of y? Yes, so it is not of 0. 0 indicates false. So it is not of false. Not of false is true. Hence, it has to be a true. Whose decimal equivalent is 1. Okay. Now, there is something called a short circuit evaluation, which we actually didn't see here. Okay. So what does short circuit evaluation say in case of logical OR? In case of logical OR, what does the short circuit evaluation say? If the first input is true, irrespective of the second, the output will be true. If the first is true, if the first input is true, then irrespective of the second, output will be true. So similarly, in case of logical AND as well, we have got the short circuit evaluation. In that case, if the first input is false, irrespective of the second input, the output will be false. Okay. Now, considering this short circuit evaluation, assume I take the input as x is equal to 10 and y is equal to 5. Okay. So I do something like this. If x plus plus or with plus plus y. So what will be the output? So what will be the output of x and y here? What will be the value of x and y? 11 and 5. Okay. So here you can observe the short circuit evaluation. X is initially 10. 10 plus plus. The value considered at that particular stage is 10. Okay. Value considered at that particular stage is 10. So 10 logical OR with. Next we'll not see because 10 is a non-zero value which is true. If the first condition is true, you don't have to be checking the next condition. The output is anyways a true. So if of true you enter into the if block. If you see the value of x, what should it be? It should have been updated to 11 because I did 10 plus plus for sure. And y is been untouched because of the short circuit evaluation. You don't check the second condition if the first is already been true. Hence x gets the value 11 printed and y is unchanged, which gets the value 5 printed. And it enters the if block. Similar to this, if you take x is equal to 0 and y is equal to 5. So I write something like this. Logical AND with plus plus y. So now what will be the output? X is 1 and y is 5. 1 and 6. Okay. So here if you observe in place of, sorry, this is logical AND. In place of this, I have to take 0 plus plus, means in place of x plus plus there has to be a 0 plus plus. 0 plus plus, the value considered at that particular stage is just a 0. Because it is 0, it is false. So if of means in the logical AND, if the first condition itself is false, you don't have to go check for the next condition. Output will be false anyways. So false will be considered. You go to the else part, and when you print the value of x, it must have been updated to 1 because I did 0 plus plus for sure. But Y is been untouched, hence Y will be 5. So X will be 1 and Y will be 5. I hope you are clear. Okay. So next, let us go with the next kind of operator. So this is about the bitwise operators now. Okay. So when it comes to the bitwise operator, we have got a few of the bitwise operators like bitwise and bitwise or bitwise XOR, bitwise left shift, bitwise right shift, and also bitwise complement. So assume I take okay, initially, what does 5 bitwise or with 7 give you as an output? Can you check? Somebody's mic is on. Is that a 7? Okay. So 5 is 0, 0, 0, 0, 0, 1, 0, 1. 7 is 0, 0, 0, 0, 0, 1, 1, 1. So output has to be 0, 0, 0, 0, 0, 0, sorry, 0, 1, 1, 1, which is 7. Remember, output of bitwise operators can be any value. Any integral value can be the output of the bitwise operator. Another thing, bitwise operators have to be applied only on integral data types. That is either on an integer or on a character. So bitwise operators should be applied only on integral data types. So yes, 5 OR with 7 is a 7. Then what is 5 AND with 7? What is 5 AND with 7? So output is 0, 0, 0, 0, 0, 1, 0, 1. So this has to give you 5 as the output. Similarly, what is 5 XOR with 7? So I hope you know the truth table of XOR. If the inputs are same, output will be 0. If the inputs are different, output will be 1. 2. Okay. So inputs are same, output will be 0. Inputs are different, output will be 1. So this gives you 2. Similarly, what is complement of 5? What is complement of 5? It is 1, 1, 1, 1, 1, 0, 1, 0 plus 1. So this is complement of 5 whose decimal equivalent. To get the decimal equivalent, you have to take the 2's complement of the number and add a negative sign to it. So yes, this has to give you -6. Now coming to the left shift. So shifting operators will take 2 operands. The syntax is, in case of left shift, it is value left shifted by number of bits. So assume I am taking a value as 5, okay, and number of bits I am taking as 2. So what is the output? What is value left shifted by 2 times? Complement operator. Complement is, oh sorry, I took 2's complement, sorry. So this is the complement, 1 1 1 1 1 0 1 0. So this is the complement. Okay, after doing the complement, this is what I have got as an value. So if this is being present in a signed variable, if I'm storing this in a signed variable, this should be a negative value because MSB is 1. And if I am storing this in an unsigned variable, the value should have to be some positive value. So to know what negative value is this, again you have to take the 2's complement 0, 0, 0, 0, 0, 1, 0, 1. To that you have to add 1. So it will be like this. Decimal equivalent of this will be 6, to which you have to add the negative sign. So to know what value is this representing, I have to go with 2's complement of the number, get the decimal equivalent and add a negative sign. Okay. So I know many of you remember complement of 5 as -6 because one of your test had this question. Okay. Anyways, it is like this. I hope you got it. Yeah, tell me what is value left shifted by 2 times? 20. Okay. So 5 is 0, 0, 0, 0, 0, 1, 0, 1. Okay. So left shifting it for ones. What is lost in the left shift? It is always the MSB is lost. And what gets filled in the LSB? What is filled in the LSB? Yes, it is always a 0. So after I shift it towards the left for ones, I will get the data like this. After shifting it for another time, this will be the data. So decimal equivalent of this is 5. Decimal equivalent of this is 8 plus 2, 10. So decimal equivalent of this is 16 plus 4, 20. So if you are observing, this is 5 into 2 and this is 5 into 4. Okay. So remember to get the resultant in case of left shift. So to get the resultant, it has to be value multiplied by 2 power number of shifts. Okay. So the resultant has to be value into 2 power number of shifts. Also remember, left shift is called as an efficient way of multiplying the number by 2 powers. Efficient way of multiplying the number by 2 powers because it doesn't have to involve complex circuitry in order to do the multiplication when it is the left shift. Coming to the right shift. So in case of right shift, we have got two kinds of right shift. One is the unsigned right shift and the other one is the signed right shift. When it comes to unsigned, again, here it is value right shifted by number of bits. And in case of unsigned right shift, what is lost? Always LSB is lost. And what gets MSB filled with? What is MSB filled with? In case of unsigned, yes, it is 0. So in case of unsigned, no, it is not 0 or 1, it is always 0. This is unsigned. So unsigned means there is only positive number. So LSB is lost and MSB will be filled with 0. Assume the value is 20. Tell me what is 20 right shifted by 2 times. That means number of bits I am taking it as 2. What is it? 5. Okay. So 20 is 0, 0, 0, 1, 0, 1, 0, 0. So after right shifting it for ones, because it is unsigned, it is 0, 0, 0, 0, 1, 0, 1, 0 and 0, 0, 0, 0, 0, 1, 0, 1. So this is 20 This is 10 and this is 5. Okay. So now to get the resultant in case of right shift, it is always value divided by 2 power number of shifts. So again, here I have to, after getting the resultant, you already know that it is an efficient way of dividing the number by 2 powers. Dividing the number by 2 powers. Okay. So, okay, when it comes to signed right shift, so again LSB is anyways lost. What is filled in place of MSB? Yes, it is always filled with previous MSB. MSB is filled with the sign bit or the previous MSB. So here assume the value I'm taking is minus 20 and the number of shifts to be performed is 2. So minus 20 to be represented in binary. First 20 has to be represented 0001 0100. 2's complement of this is 1110 1011. To this I have to add 1 like this. Okay. So I have to perform shift towards the right. When I perform it for the first time, MSB has to be retained. So it is like this. 0110 again 1111 1011. So to know what decimal value is this representing, I'll take 2's complement 0100. To this I have to add 1, which is 5. So minus 5. So this is representing me minus 5. This is representing me minus 10. And this is representing me minus 20. So similarly, this is also an efficient way of dividing the number by 2 powers. Okay. So this is about right shift and left shift. No, in the left shift, we have not got two types, that is signed or unsigned, because anyways the MSB is being lost. Always we are filling the things in the LSB. There is not like to be filled in the LSB. We have not got a choice to fill either a 0 or 1. It is always a 0 to be filled. So we have not got the categorization of signed or unsigned in left shift. Now the next one is the applications of these bitwise operators means first one is the set bit. So what does set bit mean? So what should a bit should be made? What a bit should be made if it is called set bit? Yes. So to make the bit 1, whatever it might be, I want to make it as 1. So assume I'm given with a value called x with the value 10 and I want to make it a 1 in 5th position. Okay. So for the set bit, what operator should we be using? Setting the bit. Yes, we have to go with bitwise or operator. So to set a bit of a given number, it has to be value, result has to be value or with mask. So what is the mask to be generated here? Yes, so I should be going with 1 left shifted by 5 times. So there is 1 0 0 0 0 0 0 0 1. I have to be left shifting it for 5 times. So if I left shift it for 5 times, this will be the resultant. I have to OR my data with this in order to get the bit set. So it is 1 left shifted by position times. Okay. So it is 1 left shifted by position times. Similarly, toggling the bit. So what is the operator to be used? Yes, so it has to be a bitwise XOR operator. So again I'm taking the same. X is 10. I want to toggle the bit in the fifth position. So whatever it is, if it is a 0, I want to make it to 1. If it is a 1, I want to make it to 0. So fifth bit has to be XORed with 1. Rest all other I have to keep it 0. So resultant here will be value XOR with what? So fifth bit has to be 1, the rest have to be zeros. So it is again 1 left shifted by position number of times. Next, third one is clearing the bit. So that means I want to make the bit a 0. Okay, whichever bit I want to make 0, I have to, what operator? Yes, and should be used. Whichever bit I want to make it a 0, I have to and that particular bit with 0, rest all others should be kept 1. Okay, so position I'm taking 5 again. So I want to make the fifth position 0. Okay, that means fifth position should be 0, rest all other positions should be 1. So this is the mask I should be using. And to generate this mask, you can see it is exactly opposite to this. So resultant here in this case will be value and with complement of 1 left shifted by position times. Okay, these three are the ways of setting the bit, toggling the bit, clearing the bit. These are some of the applications of bitwise operators. The next I have got is toggling the bit. Sorry, get bits means I should say the given bit is been a 0 or 1. Okay, so the given bit is a 0 or 1. Assume I take same again. Number is 10. I want to say in position 5 whether that is a 0 or 1. I have to get that particular bit and say whether that is a 0 or 1. For which I will be going with a if block. Okay. So if I do something, I'll say there is a bit set means it is 1. And if I don't get that, I'll say there is a 0 present. Okay, so clear. So set stands for 1 and clear stands for 0. Many of you are saying value right shifted by position times and with 1. Okay, so I go with number right shifted by position times means whichever position I have got, I'm bringing it to the LSB. Whichever position I want to be finding, I'm bringing it to the LSB. This I'll be ANDing with 1. So if I AND with 1 and I get a 1, I will make sure that this is a set bit. And if I don't get a 1, I'll make sure that this is a clear bit. So this will give me, after this logic has been performed, this will give me a 0 or 1. So if it is 0, I'll say it is clear. If it is 1, I'll say it is 1. So when I do something like this, number right shifted by position times, for example 10, 0, 0, 0, 0, 1, 0, 1, 0. So I am bringing the fifth bit towards the LSB. That means I have to shift it for 5 times. So when I shift it towards the right for 5 times, it will be like this. That means I have somehow brought the fifth bit to this particular position. Then if I AND it with 1, I get the LSB whether it has been a 0 or 1. So if it is 0, I will get clear. If it is 1, I'll get set. So this is one way. Another way, I also can say okay. So here I can do number directly AND with 1 left shifted by position number of times. So this time I'm taking that particular bit, 1 left shifted by position number of times. So this gives me any value, non-zero or 0. If it is a non-zero value, I'll say it is set. If it is a zero, I'll get it as clear. So here what am I doing? Number I'll keep it as it is. Okay. So I will go to that particular position and using the mask, the rest I'll keep it as zeros like this. Now when I perform and I get a 0 as the output, that means fifth bit is clear. If I get some non-zero value here as a resultant, that means there is a set bit present. So these are the two ways of getting the bits of a given number. Next, so print bits, same as this. Okay, I can use the same logic here. So I should get every bit using this. The same get bits logic I should be using, and I should get every bit from the MSB. I have to print it as it is. For which I'll go with a mask. First I have to get the MSB here. So I have to get the MSB, print the MSB. Then a bit next to the MSB, print it. A bit next to the MSB, print it. So not for 7 times actually, we have to print all the 32 bits. For I is equal to size of int into 8 minus 1, okay, it is 31. I greater than 0, I minus minus, correct. So I can go with that for loop also. Okay, I somehow wanted to run for 32 times. So I'll go with I is equal to 0 first. I'll say it in two ways. I is equal to 0, I lesser than size of int. Instead of hard coding it into 32, we can do something like this. Into 8. Then I plus plus. So I have to print it. Now, this I'll do it with a mask. I'll take a mask right now. An unsigned integer. Okay, unsigned integer mask, which is initialized with 0x80000000. Someone's mic is on. Please turn it off. I'll not be able to search who it is. It's Deepa. Deepa, please turn off your mic. Okay. So I'm taking a mask. I'll do something like this. If number and with mask, so I should print a 1, else I have to print a 0. Okay. So I'll go with a putchar. A different way. I'll print a 1, else I'll print a 0. And mask I have to be right shifting it into 1 time. Okay, this is one way. So I'm running a for loop for 8 times. Mask and with, number and with mask is being done. Number in the sense any given number whose value you want to print. Number and with mask has to be done. If that gives you some non-zero value, you print a 1, else you print a 0. And mask you have to shift it towards the right by 1 position. Else you also can do something like this with the for loop, which I just saw one of you have said it. For I is equal to same size of int into 8, just to make sure that there is 32 taken. So this is minus 1. Okay. So then I should be greater than or equal to 0 and I plus plus. Sorry, I minus minus. See here, what do I do? I'll easily write this. Number right shifted by I times. I'm bringing it into LSB and I'm ending it with 1. The same logic. So if this is giving you some non-zero value, I'll print, actually this either gives a 0 or 1. So I print a 1, else I print a 0. Okay. These are the two ways of printing the bits of a given number. Clear? Yeah, you can directly go with printf also, because that's the way we have already seen. I just went with a ternary. Okay, that is also possible. Number and with 1 left shifted by I times 1 colon 0. Yes, that is also possible. And this is when you are going with this for loop. For signed character, second condition will work. Yes, actually, but for signed character, you have to print only 8 bits of a given number. Make sure the loop is running for 8 times. So this logic runs good for signed variable, for unsigned variable, any given variable. The logic works definitely fine. Okay, so both the logics works fine for both signed variable and an unsigned variable. All right. I hope today's session was all clear. We could discuss on operators. So rest of the things will be taken up in the next session. I hope this was all clear. Yeah, if you have got anything, you can ping it up in the discussion forum, or you still can have your doubts noted, which can be discussed in the next class. Okay. So yes, to summarize, we just discussed on all the operators available, and in the next class we will start with the arrays concept. Okay, that is it. Thank you all. We'll meet in the next session.
And the hotspot